Okay, hey everybody. I saw this really cool video last night. I say last night, very early this morning, about ZOS for Linux folks. It's a really cool video, and basically what the guy does, he says what the command on a Linux system might be, and then does the equivalent on ZOS, whatever. And then I thought it'd be really cool as an introduction to IBM to do the same, but for IBM. So right now I have I'm on my Windows machine right now, and I have a 5250 emulator session running right now connected to an IBM. And I have a list in front of me of commands that I'm going to run through, and we'll talk about the file system as well a little bit. And yeah, let's just start there. So a couple of things to mention. I am on Windows right now. I am also a heavy Mac user, so I'm fairly familiar with Bash as well. Of course, using Bash on IBM too a lot. I don't have the Ubuntu subsystem, the Linux subsystem installed on my Windows machine. This machine is primarily used for gaming, so I don't tend to put a lot of development type stuff on here, other than an emulator, of course. And the very first thing we'll talk about is the file systems. So on Windows and Linux and Mac, most modern, fairly reasonably updated operating systems use a directory file kind of structure. So right now my working directory is C users Liam, and of course I can do a pwd, and that works on Windows. I have git bash installed, and so of course pwd works here. And I can see my current working directory, and of course you can use cd to go into further documents as well. Now IBM does not. Now, okay, I should also mention about IBM is that there is basically two file systems. There is uh, the QSys file system, and then there is the IFS. The IFS stands for Integrated File System. In this video, we are not going to be talking about the IFS. We are only going to be talking about QSys. And there's a reason for that, because most people access the IFS through a bash shell, or in an SSH session. Basically, we're not going to do that. We're going to be talking primarily about the QSys file system here. So the file system is a little bit different. It consists of libraries and then objects within that library. So you could actually consider it like a folder, and inside of that folder is a set of objects. That's really the easiest way to put it. So for example, I could create a library here called documents. Okay. Now, interestingly enough, objects can only consist of a maximum of 10 characters. So in this case, we're using 9. I can create that. So now I have a library called documents, and inside of that, objects can exist. So I can actually view the contents, like using the ls command. I can view the contents of this library using the work_obj command. Now, work_obj takes the path to the library. So in this case, we're just going to say documents. That would be the library that we want to look at, and then we would do /*all. So this just means show me everything inside of the documents library. So kind of like what we did here, where we went cd documents and then did an ls. Work_obj documents *all is the same thing, except we have no objects in there. And for the sake of it, I've made a file here called myfile.txt. Now what I'm going to do for the sake of this video is I'm just going to create something called a data area, DTA AI, that's what it is. So this is just a type of object, and I'll just call it myfile as well. And I'll put it in the documents library, and I'll just call it a start character, and the length, I'll just say 100. Okay, so what I've done there is created a data area called myfile. So now I can just do the work_obj again, work_obj documents /*all, and that would show me all the content, all the objects inside of the documents library or folder. So work obj is my equivalent of doing an ls, basically. Pretty easy. And like ls, you can actually filter. So I can say ls my asterisk, and it will only show me everything that starts with my. And of course, you could do that with work obj too. So I can pull up work obj, and I can say work obj my library documents / my asterisk, and it'll only show me everything that begins with my. Pretty cool. So, pretty simple to view the contents of a directory or a library. The next command I have here is cat. Now, cat on on a Mac, Windows, Linux, it's just a way to display or concatenate files together. So I can say cat my file. Oh, that's the wrong file. I can say cat my file.txt here, and it will print the contents of my file. Now, on IBM, objects generally don't have contents. Well, they do. It's kind of hard to explain. So, for example, you can view the content of any object as such unless it's a binary. Pretty much is the only way to put it. Just like like on Windows and Linux, you look at a binary and it's just hex. You just see all the hex code and the bytes for it. But on IBM, you can't even see the binary for it without some serious admin privileges. So, for example, we created a data area. And to display the content of that data area, we can use a command that starts with DSP, that's display, and then the type of object. So in our case, we did DTA-ARA. So that just says display data area. I can prompt that. And here I can say, and prompt, by the way, is F4. We'll talk about prompting in a little while. We've got that coming up here. And I can say data area, and I can say my file. And in library, I can say, documents. And I can print it, and there's nothing in there. There's nothing in this data area. A data area is literally just a string, or in our case, a character set of, just content. And so you can use display data area to do that. Now, we don't really have anything like cat as such in QSys. Now, there's also display file, which allows you to view the contents of a stream file or a database file, but that's a bit far ahead of that for that right now. Most of the way to display contents of objects is by using the relevant display command. So if you do display DSP and then do an asterisk and press enter, it will show you all of the commands that begin with display. And from here, you can actually, choose which one that you would like. So, in this case, I could say display job or, job description. And most of these match up to different types of objects. So job D, for example, is a type of object. Display lib, for example, we can do display lib, and then we could say documents, and it will just show us what's inside of that library, pretty much. Another way of saying what's inside the library. Pretty straightforward. You just have to use the display command, dsp ... and that will help you actually display the contents of an object or what the object is. It's mostly for telling you what the object is. So, okay, that's a hard one. Cat is a hard one. Next, we've got RM. RM is really simple. So, of course, on Windows, Mac, and Linux, we can use RM. I think on Windows, you can also use del, but we use RM. And I can say my file. That's not my file. I can say my file. And of course, now the file is deleted, gone. Now, on IBM, there's a few ways to do it. The first way is, of course, repeating our work obj documents / start all. Okay, and you'll notice when this menu loads that we get these options up here. Type options, press enter. So we have 2 to edit authority, 3 to copy, 4 delete, so on and so forth, 7 to rename. You get the idea. So we could actually take a 4 here and just press enter, and it would delete the object. We can also prompt it, and this is saying delete data area, and it will automatically, want to delete the, you get the idea. So there's a few ways to do this. As you just saw, it wants us to use the delete data area command when we prompt it. But you could also use delete object and prompt that. And this will just tell us to put the object in the library and the object type. So, in this case, my file documents, and then this will be star DTAARA. And it's gone. So now if I do a work obj document star all, it's gone. So delete obj is almost the equivalent of RM. That was a pretty easy one. So next we have man. Now man is what, and I don't have man on Windows here, but man on Linux and Mac is used to document commands basically. In fact, what I'll do is I'll just bring it up on the other screen here. So you give it the command and the command name, and if the documentation exists, it will actually load up the documentation. So this works on IBM and PACE as well, but we obviously aren't looking at that today. But IBM does have the equivalent. So if you're stuck in using a command, then you could easily view the documentation for that command in the terminal, which is really awesome. So for example, let's look at create DTAARA. CRT, I'm sorry. So that's create data area. This is the command that we run earlier. And if we use prompt, which is F4, it will show you what the parameters are for that command. Okay, that's really helpful. Now, what's even better than this is you can take your mouse or you can move the cursor on the screen using the arrow keys. Okay, and I can press F1 over the text, and it will tell me about that parameter. So the data area parameter specifies the name of the library using to create, and it just tells you about what each options are and so on and so forth. Now there's also a way to show additional parameters. Now this command does have additional parameters, as you can see. I used F10 there to load those up, and so for example the create data area takes multiple types. Over here we can see that, but let's have a look at some more information about that. So all I did was click with my mouse. Again, you can move it with the cursor. You hit F1 and it will show you more information about the command. So in this case, specifies the type. Yeah, this is what the command does, and this is a required parameter. This is what the DEC dec for decimal. This is a data area that contains a decimal value. And it tells you about what the differences are. Now, I don't actually use this command very often, and so let's have a look at something else. Remote location. I have no idea what this is. Specifies the name of the remote location that is used with this object. Note, and then there's notes about it. And there's a lot of documentation here. Again, I'm scrolling with the mouse. You can use page up and page down, and then F12 to back out. So create data area, and well, you can pretty much prompt any command and get information about the parameters, what it does. This is the create data area documentation. It tells you what data areas are used for. All within the operating system itself. It's really nice, really cool functionality there. Really useful. Now we're going to look at the CP command. So I'm going to go ahead and just make that my file again, and I'm going to do the same on IBM. Create data area, and I'll just say my file documents type character, and I'll just set the initial value to hello world. Okay. Data area my file created in library documents. So let's just do a work obj documents /star all and have a look at that. There it is. And again, ls my star. I have my file over here. So I want to show you about the CP command. Now there are a few ways to do this as well. Of course, the easiest way is to do your work obj and take an option 3 on the command here. And you can actually just take option 3 and then F4 to prompt it. Again, it will tell you, what the parameters are for the create dupe obj. And that's really the easiest way to do it. So this would allow you to create copy the object and duplicate it somewhere else. Pretty straightforward. So I can say to library will be Barry, or in fact, if I want the to library to be the same, I can use the constant star from lib here. That's a special parameter. And then I can say new object, and by default it uses this star obj, which is the object name. Again, if you don't know what these mean, you could just take F1 on the parameter here, and it will tell you what they mean. The new object has the same name as the original object. Same, see star obj above, same and obj have the same meaning. So, it tells you really what everything means, but let's just give this a different name. Let's call it other file. So it's going to be in the same library, and we'll just leave all the rest the same. We don't want to touch anything about the ASP right now. Let's just go ahead and do that. And we get this information down here. Object of a file in documents type data area created. So I'm still in my work ob screen, as you can see, and now I can do an F5. That's called a it'll just basically refresh. And now I have my other file in here too, which is really cool. So that really is the CP command. Of course, in Windows we could just do CP my file, and I'll just call it myfile2.txt. Or actually, I'll better keep the standard, and I can say ls, and there it is. There's my other file, and that's pretty much the CP command. Really easy. Now we're going down. We're going to get a little bit more advanced here. We're going to talk about PS, or in Windows, there's either task list or get process in PowerShell. There's a few ways to do that. So PS basically shows you a list of processes running in the current system. And it's a pretty easy command. Now, PS doesn't really function the same here on my Windows environment, but on command prompts you can use task list, not task list, task list, and that will show you a list of the processes running in the current system. Okay, kind of ugly. Okay, and then in PowerShell, you can use get process, and it's quite small, I'm sorry, and it's pretty much the same thing, almost. A bit more information by the looks of it. But we can do get process, and it will show you all the information about the processes running on this system. Now, IBMI does have an equivalent, except on IBMI we don't call them processes, we call them jobs. Although effectively they could be the same thing. And to do that, the one command that I'm going to show you here is work act job. That stands for work active job. So that's WRKACTJOB. And then I'm just going to hit enter. I'm not going to do anything else, just going to hit enter. And this shows me here a list of every active job running. There's a lot of jobs running on this box right now. And we see that we have 206 active jobs. We can also see what subsystem they're running in. That's not so important right now. The fact is we can see at a glance, kind of like what the process name is over here, we can see the function that's currently being executed on this system. So what's interesting is I can scroll down to my job. This is the job that I'm using to run this session, and so my current function is work active job. Int is as an interactive. It's cool. It's really simple. So I have, it's pretty much the same command, which is really nice as the others. Now, of course, I'd like to try and see. So here's my current process on the Windows. Got my task list here. Really, pretty straightforward. Except on Windows, we have a process ID, and Linux has the same. And I believe under the hood, IBMI does have process IDs, but we don't generally use process IDs to end jobs. So what I'm going to do here is I have an instance of Chrome open, but what I am going to do is load GitHub Desktop just for a moment. So here's a session, here's a process I have running on GitHub Desktop. And if I do my task list again, we're going to look at the kill command now. If I look at my task list again, I have, it's Electron, so of course it's going to spin up. Yeah, of course it's going to spin up these 4 different processes. And so what we need to do in order to kill that, we can just use the kill command, which is really easy actually. So, of course, kill on Linux is easy. I think we have kill. Yeah, we do have kill. That's awesome. So you'll notice here that we have the process ID, and the kill command pretty much just takes in a list of process IDs. So we could just try it. I mean, we could try kill, and I'm kind of lazy here, so I'm going to paste mine. Oh, that's not I copied the wrong thing. Alright, let's try that. Well, that didn't work very well. Let's try task kill. So task kill, I think, takes PID. Let's just do a /? Here. So it takes a PID, and we have to specify multiple, but we'll just do one. So let's just do the top one. And I think that was this one. Let's just do a task list again, just to make sure it's still running. Yep. Copy that. Task kill /PID, as in process ID, and then we specify it, and it kills the process. So that's pretty straightforward, to end a process pretty much through the command line. Of course, in Windows, you can use the task manager to do the same. Now, we have the equivalent on IBM. We do, which is really awesome. So I'm also going to run the same. So I'm going to start another session here. And I'm just going to log in. And then I'm going to actually call a program. So I'm just going to set up an environment here. And I'm going to call depths. I think that works. Oh, that didn't work. Why didn't that work? Oh. Oh. Maybe I used a different system. Okay, let's just do a work. No, let's not do a workout job. Let's do a let's just do netstat for the sake of running a job. So now, if I come back over to my work active jobs, and I'm just going to hit F5 again, that's going to refresh. Now, the first time you refresh, you'll notice this is the elapsed time since I first looked at work active jobs, and this is the current CPU percentage and the active job count. So just some useful information. So what's interesting is you can also sort by CPU usage. So if you take your cursor and you move it over CPU percentage, and then you press Shift F4, that's going to order by CPU percentage, which is interesting. Now, what's really interesting is we can see my job running here. This is the command I just ran, netstat, in the other environment. So there are two ways to end this job. As you can see in my options up here, I can use option 4, to end. And of course that means I can just take option 4 here and prompt it. Okay, that's pretty straightforward. Okay, and I will talk about this now. As you can see, the key information per job is the job name, the user that's running the job, and the job number. This actually makes up the job itself. It's a three-part name, so that's interesting to remember. There's no just single job ID. That's a three-part ID. Now, there are two ways to end a job. There are star emed and star controlled. Controlled basically tells the process, it's basically like on Windows and Linux. You can signal the process to end, and then it has 30 seconds before the system will basically say, oh, I'm going to cut you off now. Or emed just says, I'm cutting you off right now. I'm a horrible person and I always use star emed. So right now, of course, my job is still running over here, and I can do a workout job or whatever, and just do stuff in this job over here, whatever. Okay, and what I can do is I'm just going to say how to end start emed. I don't need to put anything else. That's really it, and I can just hit enter. And you'll notice over here it changes the status to end, which is really straightforward. And if I refresh, the job is basically gone now, and this is the current job I'm running. But then if I come back over to my session, it logs me out. It ended my interactive job, so then it's going to log me out. The fact is, end job, the end job command, is the equivalent of your kill or task kill, pretty much, and that's a pretty easy one to use. Cool. So next up, we're going to look at ping. I mean, this is a really simple one. Ping is everywhere. So we can ping a website. I can say ping worksofbarry.com. I don't know if this will even work, but I can ping anything I want. And of course, you can do that on Mac and Linux too. And of course, we can do it on IBM as well. I can do ping, and I can prompt it, and I can say it says remote system, so I can just say worksofbarry.com, and it's running. And it's printed this stuff out down here. It's not very useful. So what you can do here is do a display job log, and then do F10 and then Shift F6. And as you can see, it's just told me this is the command that I run, and this is the output from the command basically over here. So verifying the connection, and pretty much got the same results, as I did in my Windows machine. Pretty easy. So that's a ping. Everybody has a ping, which is awesome. So next we'll talk about command history. So as you're probably aware, on Linux, on PowerShell, on Windows, on Mac. On most shells, you can use the up and down arrows to go through your command history, right? And you've already seen me do it in this video, but you've seen me scroll back to get previous commands, right? As you can see here. So I'm using F9 to do that. You just use F9 and it keeps going back, okay? Now, on newer versions of the operating system, there's also F8, but this system doesn't have the PTF to go forward. So F9 would go back and F8 would go forward, but this system doesn't have it, and that's okay. So that's really the command history. And of course, as you probably saw when we did a display job log, it actually has all the commands that run in this job as well, which is cool. So that's command history. Next we have environment. So on Windows and on Linux, you can use the env command, and it will print out, all the environment variables for this process. Now, of course, we can also use set. That's I think set is the Windows and env is the Linux version. They pretty much look like they've returned the same thing, which is cool. So it just prints out all the environment variables, which is pretty straightforward. Now on IBM we do have the same. We have work env var, and we can prompt it, and then we get two options. We get job specific environment variables, so those are just environment and variables that are bound just to this job, and then there's system wide ones. So let's just look at the system wide ones here, and there are none actually. That's weird, but there are no system environment variables here. But if we do level job, we have one language. So we have environment variables as well. And with the work environment variable commands, we can actually add them here too. So I can say add, take option 1 here, and then say, I don't know, whatever, username, and it will ask me for my initial value, and I'll just say Liam A. And now it's an environment variable added. So of course I could come out and go back into it, and there it is. So we have environment variables as well, which is cool. Now, the last thing I want to show you is the which, which basically, which tells you what command it's going to run. So let me just go ahead and remove my environment variable there. And the last command I want to show you here is which. So which, tells you what command it's going to run when it runs. So, let's try it. Let's do. I don't even know what will work here. So which node, that's the node command. So Node.js, and I just did which node, and it would tell me what object it's going to run when I call it, which is really cool. Now IBM doesn't really have a which, but there is an easy way to find out, where an object is coming from. Really, I mean, you can just do work obj.all, and you can say, for example, let's say I want to find, how do I put this? We haven't really had any examples. Well, let's say I want to find out where the ls command comes from. I would just do which ls, right? And it will tell me where the object is, the program is for the ls command. Well, let's say I want to do work obj on the work obj command. You can just say work object, and then the name of the command, or the name of the object, more specifically, it's an object, right? And then there's the object. It exists in the qsys library, and there you go. That's really the equivalent. Now, like which actually is using the path list to find that command. Now, so is the work object parameter. So if we remember, if I do work obj documents /*all, we have two objects in there. But right now, documents isn't on my path list. So if I do a work obj my file, it's not going to be found. IBM has the equivalent to a path list, but it's called a library list. And now, as we've already spoken about, a library is just effectively a directory of objects, of binary objects. And we can actually see the library list. So like we just did echo path, we can just do display libel. And now these are the items on the library list. So work obj exists in qsys, and that's why it was found. But when we did work obj my file, it wasn't found because documents is not on here. So there are two ways to add to the library list here. To add to the path, it's pretty straightforward. You can just do set path equals, path colon, or no, it's a semicolon here, and then we can say, C hello world, whatever, and that will actually add to the path right at the bottom down there. Okay, now the equivalent to add to the library list on IBM is actually pretty straightforward. We can just there's two ways actually. There's either add libel, and we can prompt it, and we can add documents, and we can say what position we want to add it in. So if I add it to the first, it will add it to the top of the excuse me, it will add it to the top of the user section. But there's a better way. There's edit libel. This is a prettier way. So you can change and alter the list as much as you want. So I can say documents here, just press enter, and now it's on the library list, and I can do display libel again, and there it is. Now, the reason that we have sys and user here is because user is just stuff that the user has added to the library list. System ones are the items on the library list by default from the operating system when you log in. So now if I do a work obj in my file, there it is. So that's pretty much like how the which command is working. It's finding stuff based on your path list, where work obj is finding stuff based on your library list. Now the reason it does this is because the library option by default is star libel, and anywhere you see libel, it means it's going to find that object based on the library list. Yeah, that's pretty much it. So yeah, I'm trying to think. That's pretty much it. That's my list. We've just been through the whole list. So yeah, thanks for watching. See you next time.